Hello there, welcome to my channel, welcome to this video. This is the first in a series of 4 videos where we are going to be writing a password generation program. If you're new to this channel, what we're doing here is we are trying to learn Linux, specifically the Linux command line, and we are going to accomplish that by writing a series of scripts. Each iteration of the script will get more complicated, introducing new concepts and new commands. Along the way, we're going to write a README file where we're going to store these commands and concepts so that you can go back and reference them later, and so you feel comfortable with them and don't need to reference any further. So just to get started here, I am working from Ubuntu 20.4. This will also work on 18, 16, 14, pretty much any version of Ubuntu that you have. What we're going to do is be working in the terminal exclusively. So in order to get a terminal, there's a couple of ways that we can launch a terminal. The first of which is the shortcut Control-Alt-T. You see that will bring a terminal up for us. You can also click on the Applications button, type in the word terminal, and there it is right there. Now what I recommend you do is right-click on the terminal icon and add to favorites. That way the terminal's there whenever we need it moving forward. So we have our terminal. I'm going to go into full screen mode by hitting F11, and that way we can look exclusively at the terminal. Now to get started, we're going to have to use a text editor to generate both the README note file that we're going to work on and of course the script that we are going to write. My chosen text editor and what we'll be using in these videos is Nano. And the way Nano works is you type in the word nano, which is our command, and then a file name, for example, nano file, and hit enter. You'll see at the top in the center the name of the file is right there. At the bottom, since this is a new file, it's indicating we are generating a new file. Now, one thing we want to make sure of for a little bit of housekeeping is we are going to need to be able to go between different open files while we're working at some point. And the way you accomplish that is through the suspend feature on Nano. Now by default, suspend is usually enabled, and the way we test that is if you hit Control Z, it should take you back to the terminal, FG to bring it back to the foreground, and there's our editor. However, if for some reason that isn't enabled, I will show you how to do that directly from the command line. So for now, let's hit Control X to get out of the file that we were working on. That's how you close a file, is Control X. And on the command line, if you press up, you can cycle back through your history of commands. You'll see our nano file command there, and we can add in the argument or the parameter -- suspend, and that will enable the suspend feature when we edit this file. Suspend is Control Z, so the short version of that is -Z, but dash suspend is probably easier to remember. So nano suspend file, and now you should have the ability to suspend and re-enter the file. Okay, so first thing we're going to do is we are going to start with the README file, and it's going to be nano readme.bashed. You'll see we've got our file at the top, and immediately we're going to get into a bash concept, and that is the concept of comments. Whenever you write code, you're going to want to leave some comments along the way of what you're trying to accomplish through a specific task, or notes about a variable, notes about changes or updates to the script. And the way you go about doing that for the bash programming language is with the pound key or the hashtag octothorpe, however you want to call it. I'm going to call it pound key moving forward. We type in pound, and then whatever we type after that would be considered notes. Whenever I write a file, I like to put a brief description at the top of the file of what it does. So for what we're going to do, this is the reference README for our bashed scripts. And I like to put in a divider. And the way you save a file in Nano is Control O. You'll see it says file name to write at the bottom with the name of the file that we're working on. Enter, and we now have the file saved. So the first concept I'd like to cover is file descriptors. So file descriptors can be quite confusing, how they work, how to redirect them. It's a rather tough concept for some people, but we're going to start out with the most basic concept on file descriptors, and that's going to be the three major file descriptors: standard in, standard out, standard error, or 0, 1, 2. So I like to leave 4 blank lines. We got 1, 2, 3, 4. Our fifth line, we're going to put a new comment, and this is going to be notes on file descriptors. Again, I like to add a divider. So I want to start off with standard out. Now, I mentioned there are 3: standard out, standard in, and standard error. And the way we're going to do this is we are going to store these. We're going to write these comments down. The name of the file descriptor, and for each one we're going to put some examples and some notes. I like to line things up. So a nice shortcut with the Nano editor is that you can cut and paste lines through the usage of the Control-K cut and Control-U uncut commands. And when we're doing something like this where we're going to use the same thing multiple of times, I find it's just useful. Control-K twice, uncut, go down, uncut, go down, uncut. We're going to leave 2 lines between these. Let's get these lined up, and we will get into each one. So, standard out. First of all, standard out is the default file descriptor to which a command can write output. Now, if you have a hard time keeping up with what we're writing down here in these files, don't worry. Again, everything is linked to my GitHub page. You can go on there, you'll find the script we're about to write and the README we're about to write in completed version up there and ready to go. So don't worry if you fall behind. You can just go pull those copies down and have the entire thing as a reference when we're done. So if you don't want to necessarily write out everything we put here, that's okay. Make sure you pull down the README for reference later. But definitely when we're writing the script, you want to write along so that you can track the concepts. So standard out is the default file descriptor to which a command can write output. This is commonly referenced as the greater than sign. Now, I like to put single quotes around things like this when we're talking about them. And an example of this would be command. We have some kind of generic command to write output and to file. And we would take that standard output and send it to a file. Now, technically, like I said, standard output is file descriptor number 1. So when you're doing that, this is really what you're shorthanding there. By writing just the greater than sign, you are shorthanding 1 into the greater than sign, indicating that you are taking file descriptor 1 and sending it to this file. So you can write it that way, or the more common way, and that would be command to write output to file. So essentially, when your command writes output, you can write it to a file, you can write it to the terminal, you can write it pretty much anywhere. By default, in your script, when command is written out, it will be written out to standard output, which would be the terminal in the way we're going to be using it. You can, though, redirect your standard output or your standard error or your standard in to various places. We're not going to cover redirection at this time. Let's just get the concept of file descriptors, and as we get later on, we'll cover what those other options do for you. So, standard in. Standard in is the default file descriptor from which a command can read input. And this is commonly the less than sign. Again, I like to put these in single quotes. But this less than, just like the greater than, is also a shorthand. So command to read input from file, but this is shorthand for, again, it was standard in is the file descriptor 0, so this is actually shorthand for redirecting 0 in to the command. We're going to most commonly, though, see that as command to read input from file and just the less than symbol like that. The most common standard input, of course, would be your keyboard. As we are typing here, the bash terminal is reading in the input from the keyboard and then sending it to the file that we're working on. So now the last one we're going to cover here is standard error. So again, this is a default file descriptor, but this one is to which, sorry, not a great typer, a command can write error messages. And this is commonly shown in this format, but there isn't a shortcut for this. We won't be using a shortcut for this. So really it's just going to be used the one way, right? And that would be command writing error message and writing it to a file. So when you write a script, your normal output, you're going to send that to standard out, but if there's some kind of error message you're trying to relay, you would send that to standard error. And when the script is run, you can actually filter out where that output goes, whether the output is standard out or standard error, based on these file descriptors. In the first iteration of the script we're writing, we're not going to use standard error for anything, but I figured we should just cover all three here. We also won't be using standard in. Really, we're just going to be writing the password to the terminal, but I figured it was just a good idea to cover all three. So the next thing we're going to do is we're going to talk about some commands. And there's a few things we need to know before we get started. Okay? And we are going to look at some commands. We're going to track their specific syntax, or at least in the way we will be using them. We'll get an example on here to reference it, and then any notes we might want to take about that command. Okay, we're going to do a couple of these, so I'm just going to paste those down there to get started. The first thing we're going to look for or learn about is the man or manuals command. And the purpose of this command is to look up command manuals from the CLI. The syntax for this would be man and the command we are trying to query. So let's hit Control Z and go back to the command line for a second. You can clear the screen and get back to the top by typing clear. You can also hold Control L, but I'll type clear here most of the time. And we talked about man. So you can use man to look up a command. So for example, what does the man command do? Man, and it will bring up a manual page for the man utility. And you see man is an interface to the system reference manuals. So we have essentially used man to look up what man does. Something more useful might be like man echo. You'll see a list here of the various options and additional information regarding those options. Okay, and you can do this for essentially any command that is installed on the system. It's very, very helpful, especially if you have a command that you want to use something you've never used before or something you haven't used in a long time and you need to look it back up. So, man, very, very useful, and we'll actually use it for one of the next commands that we're going to cover. An example of using man would be man foo. Foo is kind of the Linux fill in the blank for random commands and text. And notes on this one is just look up manual for a command in the CLI. Okay. Again, I like to do 4 spaces between. And these next commands are going to be for printing output. Two different commands that we can look at here for just generally printing output. The first is echo that we just talked about. And the way we're going to be using echo, the syntax will be echo and then the text to print. An example of that might be echo foo. Now these double quotes aren't required. Single and double quotes are not required for the command, but it's a really good idea to quote most of what you're doing wherever you can in Bash. And especially here with echo, you can get some funny things happening when you don't quote the text that you're printing, so it's just a good idea to go ahead and throw that in quotes. And what does echo do? Echo text to the terminal or the standard output, probably more specifically, and it adds a new line character or new line at the end. So let's suspend again, Control Z, take a look at this, clear the screen, echo, foo, and there you go. You see it removes the double quotes that we put it inside of and just prints foo, but you'll also notice that my prompt, which is probably different from yours, but my prompt is on a new line. So it printed foo, went to the new line, and then printed our terminal prompt. Now this is in contrast to our next command, and that is going to be printf. Printf actually has 2 options you need to use for it, and that's the output format and then the text to print. So what is output format? In this case, we just want to print some text. We want to print it just like we did for echo. This first section here between the single quotes, this could be double quotes. I just like to use single quotes personally for this, but Inside of these single quotes, you'll see two things here. Okay, first is the actual format, right? And that's saying that this object foo over here that we are printing will be a string, and we are indicating formatting as a string with the %s. Now, if it was a digit, it would be %d. If it was a floating point number, %f. If you want to interpret some escape characters that are within that object, %b. We're just going to start out with %s. And then the next part of this is the /n, which is the escape sequence for a new line. This could be /t for a tab. It could be /t and /n. Or just in this example, we're just using /n, and you don't need to leave a space between these. So if we go back to the terminal again, when we did echo foo, you'll see we got foo and a new line. We do printf %s, and again foo, and that's the same thing we got from echo. However, that new line was added by us, not inherently by the command. If we remove that, you'll see that foo is printed, there's no new line, and my prompt comes up right there after foo. I mentioned that this formatting can be very valuable. If we should have left that at foo, change this %s to d, you will see we get an error. Foo is an invalid number. And of course, if we put a digit in there, you'll get exactly what you expected. The value in this is that you can force the object to be formatted a certain way or generate an error message and fail. Okay, so back to our terminal. So in this case, we are printing text to the terminal with manual formatting. Okay. So we are going to cover one more command. And that command is going to be the shuff or shuffle command. So let's take a look at what shuff does. Control Z to suspend. And if we type in man shuff, generate random permutations. And there's a number of options that we can pass to the shuff command or shuffle command. And we're going to be using this command to generate a random number. And the way we are going to be using this command will be shuff, and we're going to pass it some options. Specifically, we're going to use the input range option. We'll come back to that, and we're going to use the head count option. So input range is just like it sounds. You give it a range of numbers from low to high, and it will print numbers in that range. Let's take a look at that real quick. So if we do shuff, input range 1 through 9, and there you go. We got random numbers from 1 through 9. We do it again. We've got some different numbers. You see, we just random permutations. However, for our usage, we just want to get one of these random numbers at a time. And the way we're going to do that is by also adding the head count option and tell it 1. So now you see that within the range we have supplied, we print one random number. So head count and an integer. And specifically, the above syntax prints head count random numbers between low and high. So save that. Let's go up here and just put an indicator of what we're doing here. Print random permutations to standard output. Okay, so now we are ready to begin writing our script. So again, we're going to call nano, and we're going to tell it the name of the file we want to edit, and that in this case is going to be passwd for password, capitalize the G for gen, for generator, password gen. Again, we get a new file. There's the name of the file at the top. And so to start off, let's talk about what you need to do writing a bash script. So the very first thing that you need to do is that you need to tell the system what interpreter runs the script that you have written. And the way you do that is with what's called a shebang, which is a pound exclamation, and then you tell it what interpreter am I calling. So we're calling the bash interpreter, but specifically in our installation, you can use either user bin bash or most commonly bin bash. This could also be user bin environment bash, and that just tells the interpreter in your environment find bash and use that as the interpreter. Most of the time though, it's going to be bin bash. Okay, let's go down one blank line, and again I like to leave a description at the top. So what are we doing here? We are going to generate a random password and print to standard out. I prefer to put these inside of a box. Let's save that. Okay, so there's some notes on what our script does. I'm going to go down 4 lines, and first thing I like to do is put common script declarations at the very top. Now we're going to have another section for declarations, but these would be common to pretty much any script that I write, and there's a series of those. Okay, first of which is prog name, version. I like to track the creation date of the script, the version date of the script, the author, a brief description. I know that's redundant, but in a later version of the script, you'll see why we do that. And then the process ID. So we'll come back to that in just a second. First thing I'm going to talk about is assigning variables in bash. So in some programming languages, you can assign variables in multiple ways. Okay, let's start with the date, right? And that would be put a date in. And that is an acceptable assignment. But you can also, in a lot of languages, do this, leaving spaces between around the equal sign. You know, Python, awk, there's a series of languages that will accept that. PHP, same kind of thing. However, Bash will not accept that. Bash uses white space to interpret, and you can't leave the white space there because it will mess up what Bash interprets what you're trying to do. So anytime you assign a variable, it is the name of the variable equals and then the assignment with no white space between. So same idea for version. Let's give this a version number. I like to go with major and minor versions. 1.001 because this is our first version of the script. The version date, of course, is the same. The author, description, of course, we're just generating a random password. So that leaves prog name and PID. So let's start with prog name. You could hard code password gen right in as your prog name. That'd be totally acceptable. Of course, if you decide later you don't like the name password gen and you rename the file password generator, then you've got to come back in here and remember to change the program name. So instead, we are going to use a built-in parameter from Bash. So for example, when a script is invoked, you have the name of the script. In our case would be password gen, option 1, option 2, all the way up to option n. And what Bash will do is store each of these parameters in a variable. And the variable it uses is 0 for the name of the script, 1, 2, all the way up to n. Now there is a caveat that once you get over 9, you have to reference these a little bit differently. We're not going to get into that here, but just know that it does change after 9. So 0, 1, 2. Now how do you use these variables? The way you use any variable in Bash is when you want to reference the value stored in a variable, you add a $sign to the front of the variable and then the variable name, in this case $0. So our prog name, if we tell it $0, what will happen when the script is invoked is the way password gen was invoked from the command line, that value is stored in $0 and it gets transferred over to assignment of prog name. So prog name now will equal password gen. Now there, of course, there is a caveat for this as well. If we were to call password gen the way it is shown below, or shown there, prog name would equal password gen. However, if it was called by referencing password gen out of the current directory, you'd see we'd have to put the ./ in front of it, and password gen would then be stored with the / in front of it, and prog name would be assigned accordingly. If this was something more like home/bashed /password gen, then the same thing's going to happen. It's just important to know, because if you're printing this out later, you may be surprised that the value changes depending on how it was called. In a later version of the script, we'll cover how to control this. But for now, we're just going to use $0, and that will suffice. So the PID. The PID is the process ID of this script. Anytime you have a process launched in Linux, it's assigned a process ID. And this script would be no different. When you execute it, it would execute a shell, and that shell would get a process ID. So the variable for process ID, and this was a little confusing, but the variable is $. When you want to reference a variable in Bash, like I said, you precede the variable with a $. So PID is actually $. Now again, we're not going to use PID specifically in this script, but all of these listed above here, these 7 common declarations, I like to put at the top of every script that I do, and in a later iteration you will see why. So next thing is, I like to again separate the sections by 4 new lines, so 2, 3, 4, and then We're going to put a comment here, and I like to break the scripts down into sections. We're going to have an official declarations section, and what I like to do is just give it kind of a start and stop indication, and then the main portion of our script, I like to write it in the C format with the main with the parentheses. And again, the same idea, start and stop. And then these, I will leave a blank line before and after when I'm declaring, and I go 2 spaces in on my declarations, and on my executables, I go 4 spaces in. So at this point, let's save it and close it, and then we're going to call nano password gen again. Just so you know, you can use tab on the command line to complete text for you. So if I just type in PASS, it will, when I tab complete, it will find the file password gen in my directory, and it will fill it in for me. And see now we have some different colors and a different scheme going on a little bit. The green spaces here, the formatting, that green spacing comes from the formatting defined by Nano for bash or shell scripts. The yellow double quotes around the text strings indicate that we have put something inside of quotes, and it's just showing that as a text. You're going to see some different colors come up for different things. For example, when we reference a variable, it will color code it red. And there's a series of these, but just know that the color coding is specific to the way Nano is set up to interpret bash scripts, but it is very, very useful. When you look back at scripts, it'll make it easy to find certain things. So there we go. Now, what are we trying to do? We're trying to generate a random number. And we talked about using the shuffle command to do so. And we talked that we were going to use shuff input range, and see the color change there, with some kind of high to low, head count. You see that head is blue where everything else is purple, and that is because NanoRC, the Nano configuration, which is done through the NanoRC file, recognizes head as a system command similar to tail. These are commands that modify how many lines of output you get from something. And so it changes it blue because it recognizes that that is a system command, a common system command. Now what we talked about was supplying a range, for example, 0 through 9, and then printing one number. So technically, right now, we can print a password with one number between 0 and 9. So if we suspend for a second, let's clear the screen. We want to invoke this script, right? Password gen, we need to invoke this. So for now, since this is the first iteration of the script and we're just kind of starting out basic, the way we're going to go about doing this is we are going to call the interpreter manually, which is bash, and then call the script password gen. And the reason we're doing this initially is, number one, I don't want to get into teaching file permissions and additional commands to modify those file permissions from the get-go. So just to simplify things, we don't have to make this script executable. The interpreter will execute the script because of the way we've called it. But the other reason that this is good is that since we're starting out, it would be nice to have a way to check the syntax of our scripts before executing, and that can be done by passing the -n parameter or -n option. And what it will do is essentially just do a quick syntax check. It's not perfect, but it will catch glaring errors, and what you should get is no output like we got there. So let's just introduce an error into our script. Let's put in an if something, then echo, right? Now this should be completed with fi, which is just if backwards. That's how you build your if construct. However, oops, we forgot to put it in there. We saved it, and when we tested for execution, you will see that we get this line 52 syntax error, unexpected end of file. Now, that error message isn't very helpful, and the line number isn't perfect, but it's a start. So if we go back into our script, you can go specifically to a line number in Nano by Control Shift underscore and then type the number in 52. I see that took us to the very end of our script. So that's not good. But generally, with most error handlers, when you see something like this, the error occurred directly before that line. Now, the last direct line of input action that we had, it's not a comment, it's not white space, is back here. And so if you backtrack to that, you will see that's where we're missing the phi for our if command. Okay, if we were to save that, you'll now see that all is good for bash. Again, it's not perfect. There are some things that are going to get missed by it, but it's just a great quick way to check, especially when you're starting out. All right, so we know our script is functional. Let's go ahead and we check it. It's good. Let's run it. Okay, and you'll see there, that's a perfect example of a syntax error that the bash command did not pick up. How about we try again? Here we go. So we've printed the number 3, and as you see, our script each time is printing a single random number. Now, of course, that's not tremendously valuable for what we're trying to do, but it's a start. So anytime we want to store a value, we talked about assigning variables before, we're going to want to store value in a variable. And we're generating a random number, so let's create a variable called rand number, and we're going to assign it to nothing. It's 2 double quotes or 2 single quotes, doesn't matter. Technically, just this, the equal sign with nothing after it, is a valid assignment. I personally don't like that. If you go back and check a script later, especially if the script is malfunctioning, is there an error there? Was there supposed to be a value there? It's a little bit ambiguous, so I like the 2 double quotes. We're going to cover a different way to do this in a later video, but for now, when assigning an empty variable, this is my preferred way of doing it. Now, Bash does not require declarations of variables. It's not variable typed. There's no necessity on assigning it. You can assign variables on the fly at any point in your script. I just find it easier for checking scripts and housekeeping in general if you have a declaration section and you put everything you're going to use in there so that you can search later to find the things much easier in your script. Okay? Now, the way we're going to use this random number value is we will assign random number down here, but that is not the correct syntax. We'll cover that in a second. I want to go back, though. I kind of glared over something, and that is, where do we get variable names from? So you have to be careful in Bash about how you name variables because there are a series of built-in variables. So let's save this and suspend for a second. If we were to echo rand number, you'll see that there's nothing there. So that variable is not in use in the shell. But there are some other ones that are in use, like shell. Our shell has been bash. Or columns. How wide is my screen? Lines. How many lines to my screen? So these built-ins are there, and there's a series of them, and we want to avoid overlapping with those. So generally, I try to pick a 2-word variable or a 3-word variable with an underscore separating the words, and then use something that's very unlikely to be used currently in the given shell. When in doubt, you could always go back to the command line and echo the variable like I just did to verify that it's empty and it's not in use. But if you're doing something like rand and then underscore number, your chances are much higher that you're going to avoid running into another variable that is in use. Okay, we will do some different things with variables moving forward from here, but for now this is the way we're going to use them. So we need to assign the number that we just generated to random number, okay, to our random number variable. If we check the syntax on this, it's going to check out okay. So it seems like that should work. But what happens when we execute it? Well, that's not good, right? And that is because when you're assigning the output of a command to a variable, you need to execute that command in a subshell. And the way we go about doing that is by putting it in $ parentheses. So technically, the execution is done inside the parentheses for the subshell, and the $ is just referencing that. If you think that there's a chance that this output might have spaces in it, you would definitely want to double quote it. We know we're going to print out a single number here, so that doesn't matter. Another way you may see this is with backticks. Accomplishes the same thing. However, that command is considered to be deprecated, and it definitely is not as readable, so we will not be using that at any point. Just know that it's out there, and effectively it is the same thing. So now we have called a subshell, executed a command, and then the value returned from that command has been assigned to random number. We of course would need to then print that random number out. Again, put your double quotes around it. Spell it correctly too, it's probably useful. And let's go back and see if our error has gone away. There we go. So we're printing random numbers. All right, so now we have the ability to print one random number, and that's our password, just one random number. So it's not very effective. So we need a way to take that random number and append it to another number so that we can develop our string, okay? And in order to do that, we're going to need another variable. We need to store the output of multiple random numbers in some variable. So let's create output password. And go down here, and instead of echoing the random number, we're going to echo our output password. F11. Okay. Now, how do we get the random number to generate more than one time and store it in that output password? Well, this is a two-part step here. The first thing we need to do is we need to create multiple iterations of calling the shuffle command and assigning to the random number. And when you want to do multiple iterations in coding, generally that means a loop construct. In this case, we're going to use a for loop, and the syntax for the for loop is for, and then there's a condition, and then you do something, and then you're done. Now, I personally don't like putting the do on the same line. What I like to do is move it down to the next line, 2 spaces in. And then whatever action we're taking will end up here, 4 spaces in. Okay, so let's take this out of here. All right, that would be the way I would go about it. And the condition we're going to work with, this is a C construct for a for loop. And what we do is we need to initialize something, semicolon, evaluate it, and then take an action. And notice there's no semicolon at the end there. So to line this up and make it easier to follow, I'm going to do it twice initially. And so how do we initialize? We're going to pick a variable to use for the loop, and that variable, in this case, we're just going to say x. And again, we haven't declared this above. Normally I would declare this above, but we can let that slide here. So x, let's assign it a value, and that's going to be 1. Okay. How do we evaluate that value? Well, we take x and we say, is it less than or equal to some number of iterations? In our case, let's just start out with 8. And each time through, after we've done what we're going to do, let's take x and increment it. So how do we increment it? Well, you could do x equals x plus 1, or there's a shorthand for that, which is x plus equals, so 1, and that is take the current value of x and add 1 to it. This could also be 2 or 4, it could be any number. But if you're specifically just incrementing by 1, x plus plus. If you were decrementing, making it smaller by 1, x minus minus. So in our case, we're going to x plus plus. And so what do we have here is first time through x equals to 1. Is x with the value of 1 less than or equal to 8? It is. Okay. Well, we're going to increment it by 1 as we go through, but then we're going to actually go through the loop and execute the commands contained inside the loop. So let's put a comment here that we are going to repeat until password variable contains 8 characters. We're generating a random number and storing it, and store the result in rand number. I find it helpful if you're making notes about a variable to write the name of the variable as it appears in those notes. Later we'll cover how you search files for certain text, and if we were to search for rand number, both of these lines would come up in that search so that we not only get the command, but we get the notes attached to the command. One other thing, these spaces here are not required, these white spaces. This is one of the places where Bash is not requiring white space in any of this. You could glob all this together and it would work perfectly fine. Just find it's more readable in this case to stick that white space in there. All right, so now we have a loop that's going to occur 8 times, generate a random number. We need to assign something to our output password. So we assign the value stored in random number. So what happens when we execute our script? Let's check for errors first. No obvious errors. Let's go ahead. We just got one number. One number. One number. So what's happening there? Well, what's happening is that each time through the loop, random number gets a new random number assigned to it. That is then assigned to output password, and then we start again. The problem is we get a new random number, and that new random number overwrites the existing value in output password with the number we just generated. So essentially the number that's printing on the command line is the 8th iteration through the loop. So the way you handle this is you have to append the current value of output password with the random number. So the first time through the loop, output password has no value, so that's empty, and random number has some number, let's call it 3. The next time through the loop, random number generates a 7. We go to assign output password. Well, the current value for output password is 3. The new random number is 7, so output password is 37. And on until we're done. So if we check that again, Now we have an 8-digit password. You could go here and you could change this and make it a different size. However, a better practice would be to put a variable here. It's called password length. And up here, assign password length a number. See, we get the same thing, 8-digit number. If we go back in and we change this to 16, wrong one. We have a 16-digit and so on and so forth. Let's just leave that at 8. Now, when you do something like this, it's a good idea. Change this to modify. Let's do change this to adjust the final password length. All right. Now, one other thing I'd like to touch on is this appending process right here. When you create a variable in Bash, it can be uppercase or lowercase. It can contain an underscore. It can contain a number. It can begin with an underscore, but it cannot begin with a number. There are a series of characters that cannot be used. And the importance of this comes into play when you have two variables or a variable and something else and they physically touch. What I mean by that is if we were going to echo random number and the word underscore taco, this would print out the random number and a space and underscore taco. But once these two things touch, now echo is going to try to print out the value stored in rand underscore number underscore taco, which obviously we haven't assigned anything to, and that would print nothing. The way you remedy this is you contain the variable inside curly brackets, and that creates demarc limits for the beginning and end of the variable. This also allows us later to unlock some pretty nice powers of Bash with being able to modify the variable as it is expanded. But for what we are doing, we are just going to put that in as a demarc. Now, Bash obviously knows that $sign is not a valid character, and in this case, without it, it would still work, but it's a good practice to just anytime you have a variable not divided by any kind of white space with some other characters, put it in curly brackets. That'll save you a lot of headache in the future when something happens and you don't recognize why it happened and you got to go chasing that around. So what have we done? We have taken our for loop. We are iterating that for loop until the value of x reaches our password length, is actually technically greater than our password length. Each time through, we assign a random value to rand number as generated by the shuff command. And then we take the current value of output password and we append random number to the end of it, which then gives us our final output password. And that's neat and nifty, but it's really not going to be all that effective when we have a password that just has numbers in it. So how do we take the numbers that the shuff command gives us and convert them? Well, first of all, you might think, well, can I just say A through Z on the input range? And no, that won't work. Shuff wants actual numbers in the values for input range. So we can't do that. So we need another way to convert the numbers that we're getting from Shuff into letters. And we can do that through a construct. And either we can use an if statement, an if-then statement, or we can use a case or switch statement. Now, a few things to know here. Number one, when you have a lot of if statements, it gets very long and very messy and hard to follow along with. Number two, Bash will execute case statements faster than it will execute if statements. So if you're going to have to compare several things and you can do it with a case statement, that is the way to go. So the syntax for a case statement is the word case, and then there's going to be some kind of word the case is going to be comparing, and we're going to compare that in some kind of a list. And when we're done with the list, we close that out with ESAC, which again is case backwards, just like phi backwards. So this list would then contain some kind of action, and we terminate each list item with 2 semicolons. So we could have list 1, list 2, and whenever word matches either of those, it will take the action listed on that line. The way we're going to use this is we are going to evaluate random number, and we're going to start out with 1, 2, and we're going to do some kind of action. I like 2 spaces between this parenthesis and the action. It's personal preference. Doesn't matter. You do have to have at least a single white space. And what we're going to do here is we need to take some variable and assign it a letter, for example, A. So let's call this variable new letter. Again, go up here, put that in. And then the easiest thing to do, and this is going to be kind of long, but is to go through, write this out, we need to make sure our input range matches these, right? Well, we have 1 through 4, so 1 through 4. Look, this is not the most effective way to do this. This is just the way we're covering it in this version so that you can build on certain constructs and certain ideas. In a later video, we'll show you a more effective way to do this. But for now, this is a great start. Introduces the case statement and allows you to do something that's not too complex. So what happens in practice? If we escape, we can check our syntax real quick. All good. We execute it, and what went wrong? Well, what went wrong was down here. We were appending random number when really we should have been appending the new letter. Let's try that again. There you go. Now, we only have 4 letters to choose from, so it's not going to give us a whole lot. So we're going to need to expand that. But let's make a note of what we're trying to do here. We're going to convert random number to a letter and store that letter in new letter. And to make things line up nice and clean, I am going to do this. This white space here is perfectly acceptable, won't affect the way it gets parsed. But I'm going to do that because we need to get 26 letters, so at some point we're going to get into 2 digits, right? So let's just put a bunch of stuff in there. And we want to go through and just fill in these values until we get a complete alphabet. Again, I know this is kind of the long way to do it, but we're just starting out, so this is the easiest way to do it, just starting out. Element P, Q, R, S, T. And there's our 26 numbers, Q, R, S, T, U, V, W, X, Y, Z. If we did it right, we should line up nice and clean. Again, we need to go back up and change our input range to match the 26 characters that we just gave it. Save it, suspend. Let's check our syntax again. All good. And let's execute. Now, you'll see that we have a password consisting of all possible letters. We could change the length on this by going up here, changing the password length. And you see we get a longer password. So it's pretty good, but generally if we want to generate a password, we're going to want more than numbers or more than letters. So how do we mix the two together? And we could have done this a different way, with starting out with 1 to any kind of number, and then once we got through the numbers, shifting over to the letters, but I think this reads a little bit better. So what we do from here, actually 0, 1, 2, 3, 4, 5, 6, 9, 8, 9, 30, and 36, and 9. And again, need to update that range since it's now 36. And let's see what happens. Now we have a better password. We've got lowercase letters, lowercase numbers. And again, same idea here. You want to generate something a little bit longer. There you go. Now you could go through and add the same 26 letters back in uppercase, and change your range and get lowercase and uppercase letters along with numbers in your password. However, there's another way you can go about doing that, and we will cover that in the next video. So for now, we have learned some new syntax, written our very first script, which executes and generates a random password containing lowercase numbers and lowercase letters and numbers. So that's going to be it for today. In version 2, we'll expand on this idea and add some additional complexity to the password and learn some new concepts on ways to manipulate things in Bash. If you enjoyed this video, please be sure to like, and please subscribe for more videos. Thank you.